Dear friends, welcome to my video. Kindly click on the CC button for subtitles. Zero-point energy, ZPE, is a fascinating concept that arises from quantum mechanics, challenging our conventional understanding of emptiness and the void. It suggests that even when a system is in its lowest possible energy state, known as the ground state, it still possesses energy, the zero-point energy. To fully understand this principle, we need to delve into the principles of quantum mechanics and the Heisenberg uncertainty principle. Quantum mechanics is a branch of physics that describes the bizarre and counterintuitive behavior of particles at the smallest scales. It departs from classical physics in many ways, one being that energy levels in a quantum system are discrete, not continuous. According to the Heisenberg uncertainty principle, it's impossible to precisely know both the position and momentum of a quantum particle simultaneously. The more precisely one measures one quantity, the less precisely the other can be known. This has a rather peculiar implication. A quantum particle can never be completely at rest. This arises because if a particle were at rest, both its position and momentum could be known exactly, position at a specific point and momentum being zero. Hence, even in its lowest energy state, a quantum particle is not completely at rest and has residual energy. This is the zero-point energy. In the context of quantum field theory, this concept expands to all of space. The quantum fields that make up the universe, such as the electromagnetic field, have these quantum fluctuations associated with ZPE, infusing empty space with a sea of virtual particles that continually form and annihilate in pairs. ZPE has profound implications in several domains of science. For example, in the world of chemistry, ZPE explains why atoms don't simply collapse onto each other. Electrons possess ZPE that prevents them from spiraling into the atomic nucleus. ZPE also provides a solution to the enigmatic phenomenon of quantum tunneling, where particles seem to pass through barriers that they should not classically be able to overcome. The energy from ZPE can provide the needed boost to overcome these barriers. At the cosmological level, the concept of ZPE contributes to the understanding of the vacuum energy of empty space, a key component in the cosmological constant problem and dark energy puzzle. The estimation of vacuum energy derived from quantum field theory is many orders of magnitude larger than what is observed, leading to the cosmological constant problem. There are also speculative ideas about ZPE as an unlimited energy source. However, these often tend to be misrepresented or misunderstood. While ZPE is theoretically infinite, the second law of thermodynamics prohibits the extraction of energy from a system at a steady state, including the vacuum state. Therefore, using ZPE as an infinite power source remains an elusive concept. The idea of zero-point energy challenges our classical views and stretches our imagination to the limit. It illustrates the strange and counterintuitive world of quantum physics and helps us understand the world at the smallest scales. However, many aspects of ZPE are still poorly understood and the subject of active research. As we continue to explore the quantum realm, we can expect our understanding of these phenomena to become clearer and possibly unlock new technologies and insights into the universe. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.